Okay, good morning, students of grade 9 and 8 of Kumudini Kunja School, Kalimati. Today we are going to continue to our simple machine lesson, and this will be combined class for 9 and 8. Simple machine, and today we are going to discuss about mechanical advantage, velocity ratio, and efficiency, the relationship between these three terms, and perfect and ideal machine. Okay, this one we'll be discussing today. First of all, let us discuss about mechanical advantage. Acronym MA stands for mechanical advantage. Okay, now advantage correspond to the term profit, yes, and mechanical correspond to the term where force is applied, isn't it? Or mechanical relates to the term work, okay, in terms of work. Now mechanical advantage can be assumed as the profit in terms of work. Instead of work, let's say force. We need to do equal amount of work but force. Okay, the profit in terms of force is mechanical advantage. Okay, for example, I gave you an example in our previous class also in this regard. Suppose without using any simple machine, how many bricks can you carry at a single time? How many bricks can you carry? Suppose that let's say you can carry 10 bricks, okay, and each bricks having around 2 kg mass. That means the weight of each brick is 2 kg, means 20 newton. Each bricks having 20 newton mass. Your total force is, how much force you are applying? And together, altogether 10 into 20, 200. You are applying total amount of 200 newtons of force, and that is the capacity of your muscles. Okay, your muscles have 200 newtons of force. You can apply that much. However, if you utilize wheelbarrow, you all know wheelbarrow, I guess, yes, and maybe you have used wheelbarrow as well. Okay, if you use a wheelbarrow, okay, seems like it is flying. Okay, anyway, wheelbarrow, how many bricks can you load in a wheelbarrow and carry it or move it? Is it only 10 bricks? Definitely no. Let us suppose that in a wheelbarrow you can keep 30 bricks. By using a wheelbarrow you can keep 30 bricks, and since weight of one brick is 20 newton, how many total amount of force is applied here? 3 to the 600 newton. Okay, so by using a wheelbarrow, the force is, you are getting the work equivalent to 600 newton. Okay, originally you can carry only 10 bricks, but by using wheelbarrow you can carry 30 bricks. Okay, originally your force, muscle force, is 200 newton. In this case also your muscle force does not change. Still your muscle force limitation is 200 newton. Your muscles can only apply 200 newton of force. But while using a wheelbarrow, what is happening? Your force is being multiplied to 600 newtons. Your force is being magnified to 600 newtons. Now see, this what I am talking about. This is the profit in terms of force by using machine. Okay, the profit in terms of force by using machine. This is mechanical advantage. Okay, the advantage gained, advantage or profit gained in terms of force by using the machine. And here in this case, your force 200 newton has been multiplied to 600 newton, means what is by how many times your force is multiplied? 3 times. So its mechanical advantage would be 3. Now to define mechanical advantage is defined as the advantage / profit gained in terms of force by using a machine. Okay, and mathematically MA is calculated by the ratio of load to effort. That means by applying certain amount of effort, how much load can be overcome. Okay, in short, it is also written as L by E. And the way to memorize the formula is MALE, male. You will never forget this, MALE, male. Okay, okay. If just memorizing MA is not difficult. MA is equal to L by E, isn't it? However, if you do not use any shortcut methods like this, any memorizing tips like this, then you might get confused that MA equals to L by E or E by L. You might get confused in that. Okay, that's why this is good idea to memorize. Okay, so MA equals to L by E. Memorize it by male. Now, as it shows, what should be the unit of mechanical advantage? MA. Unit of mechanical advantage. What should it be? And while calculating unit of certain terms, what we do, we always take unit of all the terms involved in it. Okay. Now, unit of mechanical advantage must be unit of load divided by unit of effort, isn't it? We have been doing this several times. Now, unit of load is Newton and unit of effort is also Newton. Now they cancel each other, so there is no unit at all. Okay, mechanical advantage has no unit. Mechanical advantage does not have any unit because it is the ratio of two same physical quantity, and these are force. Okay, write down. Mechanical advantage does not have any unit. And please don't forget to make note. The effective way to study science is by making note. Mechanical advantage is the advantage does not have any unit because it is the ratio of two same physical quantity. That is what? Force. Okay, mechanical advantage does not have any unit because it is the ratio of two same physical quantity, that is force. Okay. Now another potential concept here, the reverse concept. If simple machine, if a simple machine has MA of 2, what does it mean? Okay, if a simple machine has mechanical advantage of 2, what does it mean? Now you need to apply the concept I have given here. Okay, if in this case his force of 200 Newton is being multiplied to 600 Newton. That means his force has been magnified by 3 times. So it's the mechanical advantage of this wheelbarrow is 3. MA equals to 3. And MA equals to 3 means what? The simple machine, by using the simple machine, the force, input force is multiplied by 3 times. Isn't it? Similarly, what does it mean by a simple machine has mechanical advantage of 2? It means the input force on the machine is multiplied by 2 times by using the machine. Okay, or you can also say by applying certain amount of force on the simple machine, we can overcome 2 times the load. You can give any answer. I'll leave it to you. Okay, you have to do it as today's assignment. Okay. Next we are going to velocity ratio. Okay, you know what is velocity? Yes, velocity means displacement per unit time, isn't it? Velocity means displacement per unit time. Now, in a simple machine, suppose this is a simple machine, okay, you apply some amount of effort here and you overcome load here. This is load, this is effort, and this is fulcrum. Okay, when you apply force, what happens? Effort covers certain distance, isn't it? Effort covers certain distance, and at the same time load also covers certain distance. Both cover certain distance within certain amount of time, and in this case t would be equal, and not t means time would be equal. Okay, so what is the velocity of effort and what is the velocity of load? Does effort have to gain more velocity than load, or does effort has to gain less velocity than load? What is the ratio between velocity of effort to velocity of load? That ratio is known as velocity ratio. Okay, so it virtually explains whether the work performed by the machine will be slower or faster. Whether the work performed by machine will be slower or faster. Okay, the ratio of velocity gained by effort to the velocity gained by load is called velocity ratio. Okay, that means VR is equals to what I said, ratio of velocity gained by effort to velocity gained by load, isn't it? That means effort velocity divided by load velocity. Okay, now what is the formula of velocity? You know, velocity equals to displacement by time. Yes, displacement by time, and here the displacement made by effort is also indicated by ed, that means effort distance or effort displacement. Okay, ed, and displacement made by load is also referred as ld. Okay, let me capital D, sorry, capital D here, also capital D. Okay, ed and ld. ld stands for load distance. Now what should be the relationship to calculate effort velocity? It must be, you know that velocity is equals to displacement by time taken. Yes, so effort distance by time, and of load velocity, load distance by time. Yes, now since we have double fraction here, we solve double fraction by reversing the denominator. That means numerator remains the same but denominator gets reversed, t by ld. Now you can t and t can be cancelled, therefore vr is equals to ed by ld. Okay, effort distance by load distance. Now see, don't get confused with the formula. We have ma equals to l by e, whereas vr equals to ed by ld. See, these two are just opposite, isn't it? In case of ma, load is at numerator. In case of vr, effort is at numerator. And this is what I was talking about. This is where you usually get confused. You get confused with, you know that they are opposite to each other, but where you get confused, whether it is ma equals to l by e, vr equals ed by ld, or ma equals to e by l and vr equals to ld by ed. Which one is it? You usually get confused in it. Okay, mostly in the time of exam. Yes, that is why you need some memorizing technique. As I told you, MEL means ma equals to l by e. If ma has l in numerator, then definitely VR has E in the numerator. This is how you can memorize it. Okay. Okay. Now let's continue over here. Okay. That means what if VR of a machine, VR, what does VR signifies? Just like MS signifies that magnification of force. Yes, MS signifies multiplication or magnification of force. What does VR signifies? VR signifies how faster the work will be. Okay, let's take an example. Suppose this is a simple machine, a lever. Okay, say this is a lever. If you kept a fulcrum over here, yes, and here is load, here is effort is applied here, and suppose this is this is the load arm. It is not load distance, don't be confused, it is not load distance, this is load arm, and this is effort arm. Okay. Suppose compared to load arm, effort arm is 3 times. Suppose effort arm is 3 times that of load arm. Okay. Now if you apply force here, suppose effort arm, you moved effort arm by 3 meter, then what happens? The load arm will be moved by only 1 meter. Okay, because load arm, effort arm is 3 times of load arm. Okay, that's it. And you know that if you use the similarity theorem, principles of similarity from mathematics, then you'll know that ratio of these two sides will be equal to ratio of these two sides. Okay, so if you move effort arm by 3 meter, the load moves. If you move effort by 3 meter, the load moves by 1 meter in the same amount of time. Okay, let's say that is 1 second time. Okay, now you see effort. What is the effort velocity? Velocity of effort. Effort has covered 3 meter displacement in 1 second time. It is 3 meter per second. Whereas velocity of load equals to 1 meter per 1 second. 1 meter per second. See, you can see that effort have to gain more velocity than load. In this particular machine, effort has to gain more velocity than load. That means this particular machine does not give us any advantage in terms of velocity. Okay, in terms of speed. So without using simple machine, what amount of time is needed? Okay, without using this simple machine, what amount of time is needed? By using this simple machine, you will require 3 times as much time. Okay, as much that is VR is equals to, you get 3:1, 3 by 1, that means 3. VR is equals to 3. So this simple machine makes your work 3 times slower. Okay. What about the opposite? The opposite is also true. If suppose this is a machine, and in this case fulcrum is here. Okay, the effort arm is shorter than load arm. Effort arm is shorter than load arm. Okay, in this case, see, suppose effort arm is x, then load arm is 3x. Load arm is 3 times longer than effort arm. So if you move effort just by 1 meter, then by moving effort by 1 meter, the load will move by 3 meter. See, by moving effort by 1 meter, the load will move by 3 meter. So velocity of effort would be, so effort gains the velocity of 1 meter per second, whereas load gains the velocity of 3 meter per second. Okay, so while effort gains only 1 meter per second velocity, at the same time load already gains 3 meter per second velocity. That means work will be 3 times faster, and in case VR is equals to 1 is to 3. Okay, VR equals to 1 is to 3. That means in terms of decimal it would be 0.33. Yes, VR is less than 1. So it shows that if VR is more than 1, then work will be slower. If VR is less than 1, then work will be faster. Okay, notice it once again. If VR is more than 1, then work will be slower. Okay, if VR is less than 1, work will be faster. VR more than 1, work slower. VR less than 1, work faster. Okay. Now there is another relationship. Does the common question is, does VR have anything to do with making work easier? Does VR have anything to do with making work easier? What do you think? Well, let's see. And since we have discussed that VR is simply related to velocity covered by velocity gained by effort and load. Does it have anything to do with making work easier or not? Let's see. Okay, in an ideal machine, you have studied in grade 7. Yes, in an ideal machine, what happens? Input work is always equals to output work. This is also referred as principle of simple machine, isn't it? Principle of simple machine. I will write it in bracket. If we are asked principle of simple machine, you have to write this. In an ideal machine, input work equals to output work. That means what amount of work we have done on the machine must be equals to amount of work done by the machine. Okay, what is the formula of work then? Effort into distance, isn't it? So input work means, suppose this is a simple machine. Okay, you are applying effort here, and you're keeping load here. This is fulcrum. Yes, so what amount of load you are placing here, that is effort. Sorry, what amount of force is being applied here, that is effort, and what amount of load is placed here, that is load. Yes, now what distance will it cover, that is known as effort distance, and what distance will load cover, that is known as load distance. We have this much of variable. Now in which part of machine will you be applying your work? In which part of machine will you be working? Here. You will perform work here. You will not perform work here. Okay, who will perform work here? Because certain amount of force is there, load is force, isn't it? And the force covers certain distance, means work is being performed here as well. Okay, here is also work being performed, and here is also work being performed. Effort is also force, isn't it? Here also force is applied and it covers certain distance, means certain amount of work is being performed at this point of simple machine. And in this case also certain amount of force is here and it covers certain distance, means work is being performed at this point as well. Okay, now at this point you are applying work, you are performing work, but at this point you are not performing work. The machine is performing work as a result of the work performed by you. That's why the work performed here is known as work input or input work, and work being performed here by simple machine is known as work output or output work. Okay, so how do you define work input or input work? Work performed by user on the machine. The work performed by user on the machine is known as input work, and output work, work performed by the machine on the load. Okay, user on the machine is work input, machine on the load is work output. User, the work performed by user on the machine is work input, and work performed by machine on the load is work output. Now here in this case, what is the formula of input work? You can see, since you are applying force, means effort into what is the distance covered by effort? ED. Okay, let me make it straight. Okay, now what is found the formula to calculate output work? Output work means what amount of force is being overcome by machine? L. And what is the distance covered by load? LD. Okay, so we are going to substitute this value over here. Okay, let me continue it here. Input work E into ED is equals to output work L into LD. Okay, this was the equation related to principle of simple machine. Okay, input work equals to output work equals to E into ED, and output work equals to L into LD, and in an ideal machine these two will be equal. E into ED equals to L into LD. Or now let's shuffle them. Okay, you have E into ED equals to L into LD, isn't it? Now what happens if I cross multiply L and E and ED? What happens? Here you get ED by LD, and here you get L by E. Okay, ED by LD equals L by E. So ED by LD is the expression of VR, and L by E is expression of MA. You see, what we got here is, in an ideal condition, velocity ratio and mechanical advantage of a simple machine are equal. Only in an ideal condition. Okay, in general it does not, it is not true in general, because we do not have ideal machine because of friction. We'll study that. In an ideal machine, velocity ratio and mechanical advantage of a machine are same. Okay, that's why if VR is greater than 1, then MA should also be greater than 1. That means VR means work is performed slower. Yes, work is performed slower. VR greater than 1 means work is performed slower. MA greater than 1 means force is multiplied. Okay, so a machine trades either time with force or force with time. Okay, if a machine has greater VR, then it will also have greater MA. Or if a machine has smaller VR, less than 1 VR, then it will have MA also less than 1. That means VR less than 1 means work is performed faster. Work is performed faster. And MA is less than 1 means force is diminished. See, either you invest force to make work faster, or you invest time to make work easier. Okay, so simple machine, although we say that while discussing mechanical advantage, it seems like use of simple machine is very good because it increases your force without any cost, isn't it? But that mechanical advantage is not free of cost. Simple machine is not free of cost. Either you invest in terms of time, you invest time to make work easier, or you invest force to make work faster. Okay, now let's go to next topic. Okay, next topic we have efficiency. Okay, previously we said that in a simple machine, in an ideal machine, what amount of work is input work is always equals to amount of work output by machine, or output work. Okay, if you perform 300 joule of work in machine, then the machine must also perform 300 joule of work. Okay, it's like if I give you 100 rupees, then you must give me a product worth 100 rupees, isn't it? I give you 100 rupees, but you give me product worth 80 rupees. That is not efficiency. Okay, that is not efficient. So similarly here, if you perform 300 joule of work on machine, and then the machine must also perform 300 joule of output work. However, this is not true in usual and daily scenario. In practical machine, what happens? In practical machine has to overcome friction. There is always some amount of friction. Okay, so here, first of all, you need to apply force to overcome 300 joule, isn't it? You need to apply force to overcome load, but at the same time you need to apply extra amount of force to overcome friction at this point. Okay, let's say to overcome friction, you need to apply 20 joule of work. You need to perform 20 joule of work to overcome friction. Then your total input work will be 320 joule, but output work is just 300 joule. Got it? In practical machine, a practical machine always has to overcome friction, and to overcome friction we need to perform extra work. Okay, so input work is always greater than output work. Now this is where the term efficiency comes into play. Efficiency is defined as the percentage of input work being transformed to useful output work. Okay, so what amount of input work is being applied? Out of them, what amount of work output work is being performed? That is known as efficiency. If there is no friction, then efficiency would be 100%, isn't it? 100% of input work is being converted to output work, but because of friction, that is not the case. Okay, 320 joule of input work is not converted to output work. Out of 320 joule, only 300 joule is converted to output work. So efficiency, symbol of efficiency is this eta, and it is the ratio of input work to output work. Means percentage of input work to output work. That means output work by input work into 100%. Okay, output work is defined as, we have done this previously. Yes, here see, input work E into ED, output work L into LD. We are going to place the same value here. Output work L into LD, input work E into ED into 100%. Now I can write it like this. I can separate L by E into, and I can separate LD by ED to 100%. Now L by E is an expression for MA, and LD by ED is just opposite of VR. You know, VR equals to ED by LD, isn't it? So LD by ED is just opposite of VR, so we can write it 1 by VR into 100%. So it becomes MA by VR into 100%. Okay, got it? Now this is the formula. Now it also makes sense here, this case. It also makes sense this case. in case of ideal machine, VR is equals to MA, as I told you. Here also, if a machine does not have any friction, then efficiency would be 100%, and MA and VR would be both have the value of 1:1. Okay, so this is the relationship between efficiency, MA, and VR. Okay, see, you need to revise it. Efficiency is defined as a percentage of input work being transformed to useful output work. So efficiency equals output work by input work. Output work L into LD, input work E into ED. And I can separate L by E, then LD by ED. So L by E is expression of MA, LD by ED is opposite of VR. So it gives us efficiency equals MA by VR into 100%. Now, the last topic for today is an ideal machine. What is an ideal machine? Okay, ideal is something theoretical, okay, which must be, but in practical it does not occur. In practical it is not the case. Okay, the machine which performs, okay, which transform 100% of input work into output work is called ideal machine. Okay, but it is not the case. Yes, ideal machine is not possible in daily life or in practical life, because all machine, okay, no machine is frictionless. So some amount of input work is utilized to overcome the friction. Okay, this much about an ideal machine. Okay, now you need to attempt some questions. Okay, I'm going to write the questions. Okay, freeze the screen, and then you have to pause the screen and copy the question. Okay, take out these questions as your assignment. Question number 1, define MA. What do you mean by MA of a machine being 2.5? Question number 2, define VR. VR of a machine is 2. What do you mean by it? Question number 3, MA of a machine is always lower than VR. Why? Question number 4, both MA and VR do not have unit. Why? Question number 5, what is efficiency? Show the relationship between MA, VR and efficiency. Question number 6, define an ideal machine. Why is it not possible in practical life? Okay, question mark. Question number 7, differentiate between number A, MA and VR, number B, input work and output work, number C, ideal machine and practical machine. Okay, this much is your assignment. Please submit your assignment by today evening in Messenger through personal message. Okay, then we'll continue our class tomorrow. Thank you.